the integral from x to the third, the square root of x squared plus 1 dx. If you look at each and every one of them, they're all different. They really are. I don't think you can find two that are, identical. Okay, so in this particular case, I'm going to not look at this because this is friendly. Again, this is the unfriendly part. And you can say, are you talking about friendly and unfriendly? Is that how you make a decision? No, not really. This is, for now, it's okay, but this is the problem, right? Again, I'm facing the square root of a plus b, which is fixed, carved in stone. No one can simplify that unless we use a substitution and yada yada. So u equals x squared plus 1, and du will be 2x dx. The 2 is not a problem. Then I'd have to uncover and see what I have in there. And the dx, of course, is there. So first of all, let's deal with the 2. I need a 2, and I can put it over 2, but I'd rather already take it out. So I multiplied by 2 and divided by 2. Okay. Now I have a little bit of an issue here. Why? Because I only need x from x cubed. So the 2, the x, and the dx, 2x dx, will be replaced by du. But there is a leftover. What is the leftover?
X squared.
Awesome. How do I get this x squared? Very easy. The x squared equals u minus 1. I kind of remember doing this with you, but maybe I'm wrong. So let's see what we have. The 1/2 has to stay. The 2x and x squared, the 2x and dx is du. The x squared left over will be changed into u minus 1, and this is the square root of u. Now I do remember doing this. And from here I have 1/2. The integral from, it's 1 plus 1/2, so u to 3/2 minus u to 1/2 du. And from here we have 1/2, u to 3/2 plus 1, which is 5/2 over, always the same number, minus u to 3/2 over the same number. Don't forget plus a constant c because it's an indefinite integral. So this is 1/2. I flip to 5th, u to 5/2 minus 2/3, u to 3/2 plus a constant c. I have to distribute, and I have to replace u by x squared plus 1. So this is 1/5 x squared plus 1 to 5/2 minus 1/3 x squared plus 1 to 3/2 plus a constant c. Any questions? Okay, let's go to definite. That was 54. So let's go to definite. Definite from 59 through 80. We'll go slowly so you can choose. We did this one last time. We did this one too. We did this one as well. We did this one. And we did this one, I think. I'm not sure. Anyone would like to choose?
Or 62.
You said 60 what?
62.
62. Very good. Awesome. Now let me copy it. 62. The integral from pi over 3 to 2 pi over 3 from cosecant squared of 1/2 t dt. Awesome. Perfect. Good. So I'm not afraid of cosecant squared because I know that cotangent prime is negative cosecant squared. So I already know where I'm going. But I don't like this. It's a function inside another function. This is what I don't like. So then I'm going to say let u be 1/2 t. Well, du is 1/2 dt. No problem. So what I need, I put inside. What I don't, I put it outside. 2 times 1/2 is 1. I did not change the problem. So now this becomes u. The 1/2 with dt, this, and this becomes du. So to outside, do not copy the limits of integration. Again, 1/2 with dt will be du. And this is cosine squared u. Cosecant squared, sorry. Cosecant squared u times du. Now, when x, the lower limit of x is pi over 3, pi over 3 times 1/2, I start at pi over 6. When the upper limit is 2 pi over 3, 1/2 times 2 pi over 3, I simplify and I get pi over 3. Do not copy the limits of integration from t to u because they are not the same. So then I know that this is -2 cotangent u, because when I differentiate -2 cotangent u, I get cosecant squared from pi over 6 to pi over 3. So this is -2 cotangent pi over 3 minus cotangent pi over 6. How do we determine this? Let me refresh your memory. Very easy to remember. Sine. I don't know cotangent. Who cares? Nobody cares about cotangent, tangent, yada, yada. So cosine x. So this is pi, this smallest angle, the middle angle, and the larger angle. This is 1/2. This is 1/2. This is the square root of 3 over 2. This is the square root of 3 over 2, and these two are the same. So cotangent is cosine over sine of pi over 3, 1/2 over this. So 1/2 divided by the square root of 3 over 2, when I flip them, I get 1 over the square root of 3. Or, rationalized, the square root of 3 over 3. For pi over 6 is this over this. So the square root of 3 over 2 over 1/2, this is the square root of 3. It will take me a few seconds just to, I don't have to, I wrote the table for you again, but I would have not needed that. So cotangent I know is cosine over sine. For pi over 3 is 1/2 over this, which is 1 over the square root of 3, or the square root of 3 over 3. And for this one, I know it's the square root of 3 over 2 divided by 1/2, which is the square root of 3. So finally here, the exact answer, you will not get it with a calculator. Be very careful. The exact answer is -2, the square root of 3 over 3 minus the square root of 3. Of course, I will not go add these. I'm going to factor. -2 the square root of 3, and then I have 1/3 minus 1, which is -2/3. With a negative in front, 4/3 the square root of 3. Very good pick. I never ever ask my students to sit there and learn more than this. What's the point? It will take you a blink to determine this and this, knowing that. In addition to this little table, you need to remember that cosine is measured here and sine is measured here. So here, right, it's cosine is 1 and sine is 0. Here, cosine is 0 and sine is 1. Here, -1, 0, and 0, -1. So these you need to know. 1, 2, 3, 4. In addition to that little table. But beyond that, you don't need anything. If you want to determine anything, like, I don't know, tangent of, I don't know, pi over 6. All you have to do is just divide 1/2 by the square root of 3 over 2. And you get that, the square root of 3 over 3. You don't need to memorize this because you know the ratio. I'm not suggesting that you shouldn't train your memory to memorize things and stuff, but there is no need once you have those. Okay, so let's look at anything. It was a very good pick. It was an interesting example. We want to look at anything else, any other definite integral? I also wanted to say that from the very beginning, I should have said, is this function continuous on pi over 3 to 2 pi over 3? Because if this function is not continuous on pi over 3 to 2 pi over 3, then I'm in trouble. All this is gibberish. All this means nothing. Right? Because I cannot apply the fundamental theorem of calculus. So every time I'm given a definite integral, the first thing I do is make sure that between pi over 3 and 2 pi over 3, and you can say, oh, how do I graph that and how do I look at it? Let's do it. Because we should always be aware of that fact. So please remember the fundamental theorem of calculus is not applicable if the function is not continuous. So we have cosecant. Remember, we don't have a key for cosecant. So this is 1 over sine squared. Careful how you put it in. So 1 divided by sine of 1/2 or 0.5 x, close the parenthesis, close another parenthesis, and square. Okay, be careful how you put it in. So cosecant is 1 over sine. Now, I want to make sure that I put the window exactly what I need. So pi divided by 3 and 2 pi over 3. Okay. The scale is fine. I will go from, I'm not really sure. Again, I didn't graph the function. I know how it looks like. But something like a quadratic function should look like. But I don't know. So I'm going to put -10 to 10. Okay? With a scale of 2. So when I click enter, I cannot see any vertical asymptotes. If I see vertical asymptotes, I'll have to go back to my calculations and say gibberish. Useless. Everything I've done, useless. Okay, because the function is not continuous. So right now I have to click on graph. The mode is in gradient mode. Okay, good. So I'm going to click on graph directly. If it has a vertical asymptote, or it's not, the function does not exist anywhere, then all my calculations mean nothing, just a waste of time. Between pi over 3 and 2 pi over 3, the function is continuous, so I'm safe. Okay, and as I expected, it looks like a parabola. Now, if I want to graph it to see how it looks like, then I'm going to change the viewing window. Let's say between -10 to 10, see what happens, with a scale of 1 and see what I see. Like expected, all positive because it's squared like a quadratic function, as I mentioned a few minutes ago. But I see there is trouble. There is trouble here. There is trouble here. There is trouble here. But not between pi over 3 and 2 pi over 3. That's okay. The function is continuous between pi over 3 and 2 pi over 3. That's why the calculations are not gibberish. They are legitimate. I don't know what, when you calculate with the graphing calculator. I mean, with that feature number 9. Okay, so we had from pi divided by 3 to 2 pi divided by 3. And again, you cannot enter it. Be very careful how you enter it, please. That's why I don't like this, to be honest. So it's sine 0.5 x. Then outside, if it doesn't allow me to put, I'm not finished here, but it doesn't allow me to put it after. So that's not going to work. So I have to do it again. Be very careful. I really am not fond of this feature at all. So from pi over 3 to 2 pi over 3. Okay. Okay, so I have to trick it into allowing me to put both. Okay, now it's not going to allow me to put anything in, right? Is that true? This is ridiculous. Okay. I think I got it. Let me check. I think I got it now. Okay, so it's going to give me some number. And our calculations, what did I get? 4/3. Careful with 4/3 in front. And the square root of 3. When I click enter, I think I entered this correctly in here. Be very careful how you enter it. The power should be outside. And you have to have enough parentheses. This is around this is around this, and this is the actual function. So if everything is fine, so when I think I entered it correctly, when I press enter, I have to get this 2.3 blah, 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 blah. Okay? So careful, it's not that easy to put it in correctly.